Take a look at almost any vehicle on the road, and you'll notice one thing they all have in common: rubber tires. Cars, buses, trucks, motorcycles, and bicycles all rely on rubber because it provides grip, absorbs bumps, and helps vehicles safely navigate turns and uneven roads. But trains seem to ignore that rule completely. Instead of rubber, they roll on smooth steel wheels over equally smooth steel rails. So why do trains use steel wheels instead of rubber tires? Today, we'll explore why it continues to use steel wheels and why that decision remains one of the smartest engineering choices ever made. Let's dive in, right here, on History of Simple Things. One of the biggest reasons trains use steel wheels is something called rolling resistance. Every time a wheel rolls across a surface, some energy is lost because both the wheel and the surface deform slightly under the vehicle's weight. Rubber tires compress significantly as they roll, constantly flexing and generating heat. That wasted energy means engines have to work harder to keep the vehicle moving. Steel wheels behave very differently. Steel is extremely rigid, and steel rails are equally stiff. So there is very little deformation where they meet. Because almost no energy is lost, trains can move enormous weights using surprisingly little power once they are up to speed. In fact, rail transport is among the most energy-efficient ways to move freight and passengers over land. A single locomotive can haul dozens or even hundreds of rail cars because each steel wheel encounters so little resistance. If trains used rubber tires instead, the additional rolling resistance would dramatically increase fuel or electricity consumption, making rail transport far less economical. Another key advantage of steel wheels is their ability to carry extremely heavy loads. Freight trains can weigh thousands of tons, and even passenger trains are very heavy before boarding. Steel handles this pressure well because it is strong and resists deformation under constant stress. The contact point between wheel and rail is very small, yet it supports enormous forces without failure due to the strength of steel and the rigid rail structure. Rubber tires would flatten under such weight, wear out quickly, and overheat from constant flexing, making them impractical for rail transport. Even heavy-duty tires used in mining trucks cannot match the loads carried by trains. Steel wheels also distribute weight efficiently through the rails into the sleepers and ballast below, creating a stable and durable track system. This design allows trains to move massive loads safely, repeatedly, and efficiently over long distances with minimal wear and high reliability. It might seem strange that trains use wheels with relatively low grip. After all, traction is important for most vehicles. Cars rely on tire grip for accelerating, braking, and steering. However, trains work differently because the rails guide the wheels, so steering isn't needed. Instead, they simply follow the track. This reduces the need for maximum grip and allows lower friction, which improves energy efficiency and helps trains travel long distances with less power. Still, trains must have enough traction to start moving and climb slopes. The heavy weight pressing steel wheels onto steel rails provides enough adhesion in most conditions. Modern locomotives also use electronic traction control systems to prevent wheel slip, especially in rain, snow, or ice. When extra grip is needed, some trains release sand onto the rails. Rather than relying on rubber tires, railways manage traction through weight, engineering design, and advanced control systems. Steel wheels are highly durable and remain stable even at very high speeds. Passenger trains traveling above 300 kilometers per hour generate extreme forces, yet steel wheels keep their shape for hundreds of thousands of kilometers. In contrast, Rubber tires wear quickly on rough surfaces and are more prone to punctures, blowouts, and heat buildup as speed and load increase. Steel wheels still require maintenance, but they can be reprofiled on specialized lathes instead of being fully replaced. Rails are also regularly ground smooth to ensure a consistent running surface, extending system life. Together, these practices keep both wheels and tracks in service for decades. Steel performs reliably across extreme temperatures, from freezing winters to hot summers, without significant changes in behavior. Rubber, however, becomes softer in heat and stiffer in cold, and it ages faster over time. This consistent performance makes steel essential for rail networks to operate continuously and safely. Although steel wheels dominate conventional railways, rubber-tired trains exist in some specialized metro systems. Cities like Paris, Montreal, and Mexico City use rubber tires on concrete guideways, often with steel backup wheels. They provide faster acceleration, quieter rides, and better climbing on steep gradients. However, they consume more energy due to higher rolling resistance and require frequent tire replacement. They also operate mainly on shorter routes compared to traditional railways. For long-distance travel and freight, steel wheels remain far more efficient and cost-effective. Research continues into new materials and wheel designs, but none match steel's overall performance. Steel wheels on steel rails still dominate global rail networks. Despite appearing old-fashioned, they remain unmatched for moving heavy loads over long distances. This is why most modern rail systems continue to rely on this proven engineering solution worldwide today in operation globally. Steel wheels suit trains better than rubber tires due to low rolling resistance, high strength, and rail guidance. They efficiently carry heavy loads, require less energy, and last longer. Though rubber-tired trains exist in cities, steel-on-steel remains the most efficient, durable, and proven railway technology after nearly 2 centuries today. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.